You have begun to do the things. I'm thrilled for you. Let's make sure you're doing the things properly. So, again, this will feel painful, especially to those of you who are in like pre-calculus 12 or calculus already, and you're like, why are we doing this? This is trivial. But this isn't trivial for everybody. And this is a physics class, not a math class, so I want to make sure that all the math we got to do, we're all on the same page for. So humor me. If it feels like I'm holding too many hands, that's okay. I would rather hold too many hands than too few hands, and then have you all drown. We don't want that. No drowning in physics class. So we'll do a couple of these just to make sure we're all on the same page. Here's the formula. This formula, it feels like it kind of comes out of nowhere. This is the formula that we're going to use in the next chapter. It relates these concepts together, VF, VI, A, and D. You might have some ideas what those concepts are already. Yeah, it's the same booklet you already have. Same booklet. We want to determine the value of D if we have been given a particular set of values. VF is negative 20, VI is negative 10, and A is 3. So I want you to have your calculators out. I want us to be comfortable with how these things roll, and I want to make sure you're punching things into your calculator properly. So the way I want to see this, as you guys are going through this, is to start by, well, we've got the formula written for us conveniently right there, and we're going to work right below it. So when you've got values, especially if any of them are negative, to make sure your calculator is actually working the way it's supposed to be working, we want to make sure you're using brackets properly. So when you're replacing a variable with a value, the first thing you want to do is you want to place a set of brackets where the variable was, and then you want to insert the value into those brackets. So VF we're going to replace with a set of brackets, and then we're going to take the value for VF. Screw you, fire alarm. There it is. We're just replacing everything one after the other. So we've got a value for VI. VI is negative 10. So again, bracket, negative 10, close the bracket, squared the thing, plus this pen sucks. Plus 2 times 3 times D. Can we see the light blue if I use the light blue? Are we cool with that? Okay, back basically Isabella. If you can see it, everyone can see it. You're good? Okay. And now we go through it. We simplify what you can, or you can move stuff around and just punch it in your calculator all in one shot. Either way, I would like to simplify it first, just piece by piece. 2 squared is 4, so 20 squared is 400. It's going to be 400 equals 10 squared is... Now, negative 10 squared is positive 100. If you don't put those brackets there, your calculator will read this to you as if it was negative 100, and you'll just accept the value and move on. If you've got to be real deliberate about how you use the brackets to make sure your calculator gives you what you need. Plus 2 times 3 is 6D. And now it's just algebra to go ahead and solve this thing. Yes, Abdu?
What about the square on the S? What 3 m slash S?
Those are units. So these are units, these are units, these are units. We don't have to insert the units into, I'm not going to make you at this stage, insert the units into the variables.
They're not the same unit though, it changes. Because one of them has a square on it, right? So.
Okay, I'm going to do it again, but I'm going to insert just the units, not the values. So we've got VF squared equals VI squared plus 2 times A times D. VF is, those values all have units of meters per second. So we're going to get meters per second in brackets squared equals meters per second in brackets squared plus 2 times meter per second squared. The squared's on the denominator this time, as you know, as you pointed out, times D. Now, D is probably going to be what? In science, the letter D probably stands for a
50?
no, a value, not conceptually. No, I don't want the number. I want, what does the letter D represent? Is it a
Distance.
a distance? Distances are measured in meters. So now we can go ahead and look at this thing. If I square these units, so just using exponent laws, it's going to be meters squared over seconds squared equals meters squared over seconds squared plus 2 times meters over seconds squared times meters. meters times meters is meters squared. So the units are this, like, we have meters squared over second squared, meters squared over second squared, meters squared over second squared. Even though the units are different as we're inserting them, I mean, we treat the math, even though they're just a bunch of letters, the exponents get treated like they would anytime you square a fraction. The square root is already part of the denominator. When you multiply a whole number by a fraction, this becomes over 1. Meters times meters is meters squared. Second times 1 is just second squared. The units will still work out. Cool? Okay. So then, as Levin said, the answer is probably 50. Let's take a look. Again, you want to make sure you're doing BEDMAS properly. The first step to BEDMAS here is to do what? Yeah, we want to move the 100 over. That 100 is positive, and it's being added to the 6D. So to move the 100 over, what do we got to do?
We have to minus it from the 400.
We subtract it on both sides. You betcha. It's going to cancel there, and we're going to get 300 equals 6D. Now we have to get rid of the 6. Divide both sides by 6 because we're multiplying it by the D, so we're going to cancel that. 300, I don't leave quite enough space. 30 divided by 6 is 5, so 300 divided by 6 is 50 equals D. And we're done. Sorry? He's right. I'm getting the impression that Levin's done this all before, and so I'm going to take him at his word most of the time. You don't often get a grade 10 taking a Physics 11 course. Also, if I'm not mistaken, he's German, and they do things earlier in Germany. Okay. Shall we do another? Yes. If you did example 2 already, there's a problem with example 2. So we're going to tweak example 2, and we're not going to make it 120. We're going to make it 125. Because I want to make things work out a little better. The formula is the same, but now we're solving for something slightly different. But the procedure is the same. 125 squared is going to equal, you take your VI is what we're looking for. So that's going to stay VI squared plus 2. The A we're going to replace with a set of brackets, and we're going to put the value for A inside there. And we're going to do the same thing with D. And now we can simplify where we can. 125 squared is... You all got calculators here. You could plug it in. If any of you can do it in your head, that'd be very impressive. 15,625. You betcha. Equals VI squared plus 2 times 25 is 50. 5 times 3 is 15. So we're going to add 3 zeros to that. 15,000. Or you could just run this piece through your calculator. We're going to... how are we going to get the VI by itself? What's the first step we got to do? 11. Yeah, so the first thing we got to do here is we've got the VI squared plus 15,000. The mistake I see all the time is that students at this stage are going to start square rooting things. Do not do that. When you're isolating for a variable, you're basically running BEDMAS backwards. If you have addition and subtraction, you got to get rid of that first. Then you got to deal with the multiplication and division. Then you have to deal with any exponents. BEDMAS is traveling in reverse when you're isolating for a variable. So we're going to take away the 15,000. Take away the 15,000. We're going to be left with 625 equals VI squared. To get VI by itself at this stage, because we're squaring it, the opposite of squaring is square rooting. I'm going to go over here. Square root of 625 is 25 equals VI. Comments, questions, concerns? Okay, cool. If there's no comments, questions, concerns, I want you to do example number 4. Do. You do. And the market say go. Yeah. Excellent. What'd you get? Do example 4. When you're done, put your hand up. I'll tell you if your answer is right. No. Yes.
Oh, mom.
No. It's not your mistake. You made the classic mistake of math students everywhere.
Negative.
Yep. You dropped a minus sign somewhere. Find it.
So what did you get? That's a great question.
Where did it go?
Which one did you get? 4. Oh, you made something negative. Oh my. You lost your 8. I have silence. I have like. I think it is like saying
Right.
positive.
Substitute the values in before you. When you've got a value, throw your hand up so I can check it. See, it's even like when I was a university student, questions are obviously not questions are multiple page long,
Yeah.
so we set up pages and we'd just go, we'd start writing. Often how it works in the university is just you know the result you're trying to get
Oh.
and you're proving.
Okay.
Like, find this result, you're like, I know, so you get to the end of it and you'll be out by minus sign. Where did it go?
And then so many pages.
So you kind of work your way backwards, knowing that it's supposed to be there. And if you couldn't find it, often what we would do is we'd just be like, if it's like 4 or 5 pages long, we'd just go into the middle of page 3 and it's like, that negative falls all the way through cool. And then we changed it everywhere. And often our professors wouldn't find it buried within there. No idea. But that is the classic mistake of math students everywhere. You got a number? You got a number for Oh, how much more? Do example number 4. I skipped 3 before. Or Andrew.
I think it's work.
There you go. Love it. Do number 4. When you've got a value, let me know.
So minus 1/3. Yeah. You're doing that. Plus 1/3. Yeah.
A value?
And if a.
Do you need a calculator? Do you have a calculator?
You have to multiply by 2.
In physics, sorry, in math, we all are cool with fractions. In physics, we all want decimals because we have more meaning with decimals. So you don't have a calculator on the camera.
Divide by 2.
Got a value? Not yet. Yep.
I would even avoid it. Let's just do the actual.
This is all just multiply, right? Multiply together. So like up here, I just think 25. Okay, also half times.
The formula for this complex
So then just
is C
simplify that down to 8 days.
Where is that?
That's not good. I don't think you have it. Nope, like this one. That decimal has to be wrong.
Do I have to?
Take care of someone. It's like, what?
Is the diagram? Yeah, good one. It's pretty good. Using its circumference.
I got a negative.
The average cost of is
Very first step.
now do
We need minus 4. There is no minus sign.
16? That is 16.
So these are multiplied together. Second total. It's not easy.
Yeah.
their math, this is not our math. Math's just a question.
It's not like you're on. It's good on. I know you are.
Okay, you two are good.
Okay.
Go out again.
That's, what do you call it? I
Back to this again.
Simple interest. Oh, we're doing math, we're doing taxes.
Okay.
Where's your-
Taxes. But I thought you were doing A squared plus B squared is C squared.
Don't draw myself with that.
I think that's zero.
Oh,
A
this is only the half of the 6.
Yeah, relationships, what one? Sine,
Yes.
cosine, or tan, all of it, is it 30, 39?
Yeah, that's
Is it all of it?
That is correct. Yes, that's correct.
Don't worry about it.
Oh, hey, you're good up to the last. This is eight. So what operation? Yeah. So how do you do multiplication? You subtract it. You have to divide. If you're undoing the operations that are run, if it's 8 times 8, you have to divide by 2. Good up until the last step. How are we doing? What's going away? Oh, we don't have what's happening. How are we doing over here? Borrow pencil. Got that in? Yeah. You're going to have 4 on 3. Well, who's the one I tell you first? Yes.
Yeah, but we're like,
So what's your question? So what's your question? So these 3, because there is no operator between them. Yes, times this. So you can, when you've got 3 things multiplied like this, you can multiply them in any way you want. So you can just go like this. Half times 16 is half of 16. Half of 16. Half of 16. So this is going to be when you do this half of 16 minus 8. And then you have 190 equals. So then this being this one stays the same. Minus. Now you now you subtract over and you divide by the negative. Oh yeah.
oh, no,
190.
Oh,
Normal example, why you short. That's the only mistake. I look at all your other words. If that becomes 112, that becomes 112, that becomes 78, and then what your dog's correct. This is a perfect example of why you show me work. Because I can just okay.
Oh, that's
So you 9.75?
yeah.
At this point, I'm hoping that we've got negative 9.75. Okay. Yeah, I'm just going to the last step. This is good. 78. Okay. Yeah. So I want to show you all just to make sure that some of the bits and pieces that that show up here, some of the nuances to what we've just done, make sure we're all on the same page. There were a few of you who got an incorrect value and didn't show me enough work to work with. There were a few of you who showed me all your work, and so it was really easy to pinpoint exactly where the mistake was. This is, for those of you who did that, this is exactly the perfect example of why I want you guys to show your work. So let's plug it in here and make sure we're cool with the process. D is 190. I'm just going to work right below. VFT. If there isn't, so VF, the way this is written, this is a single variable, and you can see that right here. VF equals 28. You might not be used to seeing a variable with a subscript. We're going to use them all the time in physics. That's what that means. Between the VF and the T, when there's nothing written, there's no operator there, the operation is multiplication. So what we're going to have here is we're going to have 28. We replace the VF with a set of brackets. We put the 28 inside. The T is also going to get replaced with a set of brackets. We put the 4 inside. Again, there's no operator between them, so we're going to multiply here. Minus 1/2 A 4 squared. And this is where some of you, where I got some of you. 190 stays 190. 28 times 4 is 112 minus 1/2 A 16. And this is where some of you guys got stuck. With an expression like this, because all three of these things are just being multiplied together, you can multiply in whatever order you want. Like if I had 2 times 3 times 4, I could say 2 times 3 is 6 times 4 is 24. Or I could say 2 times 3 times 4 is 2 times 4 is 8 times 3 is 24. You get the same result. You can swap the ordering around if all you have is the same operator. So instead of doing half times A times 16, I could do negative half times 16 is going to give you negative 8. And then the variable A is just going to hang on for the ride. So this is going to become negative 8A, and then the 190 and the 112 and the equal sign just stay there. And we work down from that. Now the next piece that we're going to isolate is what? The 112. And because the 112 is positive, even though it's, so this is another common mistake I see, where you've got 112 minus 8A. A common mistake I see is students will say, there's subtraction there, so I'm going to add over. That's not the way we want to do it. We want to look at the 112 and we want to say, okay, I'm adding, subtracting between these two. The 112 is positive, and it's the sign on the 112 that dictates what we use. 112 is positive, so we subtract it over. So we're going to get 190 minus 112 equals negative 8A, and that, Sienna, is probably where you drop the minus sign.
Yeah.
I told you, it's a classic mistake for ages. 190 minus 112, you can use your calculator for that. I've got no judgment, but that's 78. Minus 8A, divide by negative 8, divide by negative 8. And you're going to get A is going to equal 78 divided by negative 8 should be negative 9 and 3/4. Now, I told a few of you, some of you like to operate in fractions, and that's fine. Fractions are great in math. In a math class, when you want exact values for things, fractions are beautiful. Love fractions all the time. I'm not teaching you math, I'm teaching you physics. In physics, math is a tool, and we like approximations when we're dealing with the tools. So I want decimals. Because 0.75 of a meter, for example, actually has meaning. It's 75 centimeters. It's about that big. But if I tell you 3/4 of a meter, lots of us we struggle with conceptualizing fractions. So I like decimals in physics. Are we cool with example number 4? Comments, questions, concerns? Okay. I will leave 3 and 5 off, and I want to flip the page for the sake of some time and the fire drill we just lost. We're going to look at rearranging some formulas now. So we're going to use the exact same set of skills, but instead, this time I'm not going to give you values. I'm just going to say, here's a formula, move the formula around. The skills are exactly the same. We just don't get to simplify anything, and that's okay. So, let's do a couple of these. I said it before, and I'm going to say it again. We're going to write it across the top here. When you're solving things, we like BEDMAS. If I give you an expression that has a bunch of numbers in it and there's no letters anywhere, we BEDMAS the thing. But when I give you an expression with a variable and you have to isolate the variable, you have to solve for the variable, we're going to go backwards. And we're not going to BEDMAS, we're going to SAMDEB. Don't know who Sam and Deb are, it doesn't matter who they are. But when we're undoing BEDMAS, we're going to isolate using SAMDEB. So, I've got an expression here, a relatively simple one. We want to solve for m. They're going to get gross, and that's okay. Start with nice and easy. I've got f equals ma, and so when you see, there is not a single symbol on there other than an equal sign. So what are the mathematical operations going on here? We're multiplying between the m and the a. So if I want to solve this thing for m, because I'm multiplying these two, how do I get m by itself? Love it. Yeah, we want to undo the multiplication, so we're going to divide by a. And the thing that students don't seem to like here is that because there are no numbers, there is nothing to simplify. But that's okay. At the end of the day, we're done. M is going to equal F over A. And now if we wanted to, we could plug in values for F and A and give us a value for M, for example. Second one's similar. I got E equals MC squared. Famous equation. Very few people know what it means. Well, not very few. More people don't know what it means than do know what it means. But we're going to solve for C. Yes, Levin.
Divided by M.
Yeah, so I've got M times C squared. If you look at SAMDEB, we're undoing bed mass. There's no subtraction or addition. There is multiplication. We want to deal with the multiplication and division before we deal with this exponent. So, as Levin said, to undo this multiplication between the M and the C squared, we're going to divide by M. Divide by M, divide by M. M over M cancels. It's 1. And so what we're going to get here, toss an arrow in there, is that E over M equals C squared. And now I don't want C squared. The question says to solve this thing for C. So to undo the squared, the opposite operation of squaring something is square rooting something. So we take the square root of all of both sides. Square root there, square root there. Because these are opposite operations, the squaring and the square root, they cancel. And so now on the right-hand side, I am truly left with C. And that's going to equal the square root of E over M. And that whole fraction goes inside the root. Comments, questions, concerns for me so far? Okay. If there are no questions, let's do number 3. I'm going to do a bunch of examples here, and then I'm going to give you some time to practice. You probably won't have time today because we lost so much time to the fire drill. Okay. Number 3. I've got EP equals MGH. This is a formula you should recognize if your teacher in Science 10 did their job. And I did my job last year. So there's a bunch of you that should recognize what this is. What are you calculating here with EP equals MGH? Science 10. Sorry? It is not kinetic energy. It's the elastic potential energy was half kx squared. We did do that with me though too. MGH. G is gravity. So this has to do with gravity. This is gravitational potential energy. Is that what you just said, Saf? Okay, so I want to solve this thing for G. I've got M, G, and H with nothing written between them, so what mathematical operation is going on in there? I've got M, G, and H with no mathematical operators written between them, so what is actually happening there? We're multiplying everywhere. So to undo the multiplication, we are going to divide. Now, it depends how you're comfortable with these things. You can divide everything that you're multiplying by in one step, or you can do it one at a time, and you will still get the same result. I will show you. I'll try and justify why that's true. I'll show you it one by one first. If I've got MGH, I want to get G by itself. So I'll get rid of the M first. Divide by M, divide by M. There, it's canceled. So now I've got GH equals EP over M. I've got EP over M equals GH. Now we'll divide by H, divide by H. Boom. So now I've got an expression for G that looks pretty gross. We don't like stacking fractions. G equals EP over M over H. Alternatively, we could have dealt with all of the multiplication in one step, which is kind of what you guys did before. When you had a half times A times 16, lots of us said, okay, well, I've got a half times 16 is 8, and then I divided by the 8. You can do it with letters, too. I'll write it again. I've got EP equals MGH. Instead of dividing by one at a time, I'll divide by both of them. I'll divide by M times H. Divide by m times h. The m's will cancel, the h's will cancel. And at the end of the day, we'll have g equals ep over mh. And believe it or not, these two expressions are the same. Sorry. Both are totally valid expressions. Would you like me to? Would anyone like to see how they are the same? Jedediah says no. Why would we do that? Are we cool with why they're the same? So Andrew, you don't know and you don't want to see.
I'm not cool with them being the same, but they are. I agree that they are.
You'll accept that they are, but you don't like how it looks.
Yeah.
I mean, it's one. You know what? I'm going to show you anyway. Then, fine, Andrew. It's one simple step. When I've got a last EP divided by M divided by H. When you've got stacking fractions like this, what we could do instead of dividing here by H, is I could just multiply it by 1 over H. I could just say, okay, dividing by H is the same thing as multiplying by 1 over H. Just rewrite it. And now when I multiply the thing by 1 over H, when I multiply a fraction by a fraction, EP times 1 is EP, and M times H is just MH. It has to do with what it means to divide. And recognizing that they are the same is an important skill to have. Okay. I want you guys to do number 4. Go. Try number 4. Yes, I know you're done, Sienna. As you pre-calculus students should be done.
We were not the sir. Yeah.
Sorry?
We were not the sir. How do you do that?
See, some of you're coming here. You walk right out of a pre-calculus 12 class. Some of these guys are coming out of
Yeah.
Big gap.
Oh, only a little gap. 2 years ago for us, was our home had to be
It's W10. Pre-calc 12. Like that's
I'm a student in this class, but I want to do science, math, or business degree. I'm like, oh, so they're like,
I didn't say, I don't know if I said you shouldn't. Everyone should take physics 11. But most people don't unless.
no, I mean like pre-calc. That's the first one.
Oh, in pre-calc.
Yeah.
Oh, okay. I would never tell you not to do it. Pre-calc 12. I mean that is who it's for.
Yeah. And I was like, oh, I'm in this for the long run. I was actually. Then you just have to.
Pre-calc 12 is actually now. Yeah. Nowadays, Foundations 10 is actually the worst math course. Because the jump from 9 to 10 is bigger than anything.
Really?
One can make an argument for pre-calc 11, but pre-calc 12 is not the hardest math course.
Yeah,
Yes.
I think quadratics nice. Yeah, so I failed the first time for 37.
Yeah, I didn't even pass one. I trick saved my life.
It's not more proper, it's just an alternative.
Yeah, no, I
There are two totally acceptable expressions with this. You have those fallacy? I think it's hilarious. Especially when you guys do it.
So
That is you want to either divide by half or multiply by 2. You go to the right hand side. We should have
Oh, yeah.
Oh, so it's something.
Yeah, I have them in,
It's short. Yeah, make it like negative.
oh, I feel
This is good, that is good.
It's.
yeah, I know. I know. But it's like negative.
That is a way to write this thing, yes.
Why not divide it by
A way. Yeah, I love it. Yes.
I got EK over V squared. You can look at it.
That's a way to do it. Okay, let's take a look at 4. What do we get? There, I saw a bunch of different expressions, all of which are totally valid. So, and then one of the things Andrew said is actually something I want all of you to be aware of. Andrew said, well, I have this answer, but I'm not technically sure it's the best way to demonstrate it. Like it was, there are multiple ways to demonstrate the solution for this, and I mean, there are, I would say, of the 3 ways that I saw, there are 2 that are more elegant, but they're all mathematically equivalent. None of them are wrong. So I'll show you, lots of you are good with where we got. I think I got to most of the tables. Values, or the expression, sorry, that we're looking for, one of them would look like this. M is going to equal EK divided by 1/2 V squared. That is one of the ways I saw this written. I think, Andrew, that's the expression you had. Totally acceptable. You divided by, because you're multiplying 1/2 times m times v squared, you just multiplied by you divided by 1/2 and v squared all at once. Totally acceptable way to write this. I saw another expression that said, I'm going to divide them piece by piece. Someone said, okay, I'm going to write it as EK divided by v squared divided by 1/2. Ugly, but totally acceptable mathematically. And I mean, I like elegance, but this isn't a math class. A little bit of ugly math never hurt anybody, as long as you're comfortable with using it properly. The other way that I saw it written was, instead of, so we saw 1/2 times m. Because we've got 1/2 times m, lots of you guys wanted to divide by the 1/2. That's totally fine. Vikram, you wanted to multiply. So if I'm getting 1/2 times m and I want to get rid of that by multiplying, what should we multiply by? We should multiply by 2. So if I multiply both sides by 2, what's going to happen here is you're going to get 2 times EK, and then you're going to divide down the v squared. All 3 of these are mathematically equivalent. None of them are better than the others. These 2 are more elegant, but at the end of the day, they will all do the job. If you didn't get one of these 3, let me know, or let Ms. Crousson know, and we can come help you with that. But one of these 3 expressions is what you're looking for. Okay. How do I want to play this out with the time that I have left? Sorry? Throw you a party.
Yeah.
That would be a horrendous idea. Oh.
Wait, it's Tuesday.
Stupid fire drill. I would like you guys to, in the time that remains, and we'll call this your homework, I would like you guys to do, with what we've done, I'd like you to try the last 4. You've got lots of space on the page. I want you, if you want to move to the whiteboards, go for it. I would like you to work, because we're up against lunch here, I'd like you to work to the bell. Try these 4 questions in the space you've got available, and I'll go over them tomorrow. Other than those 4, you've got no homework. Tomorrow we'll have a bit of a work block to make up for some of the time that we didn't have today. Okay, those 4, Ms. Crousson and I are available to help. Do not pack up unless you're done. On your mark, it's at Giver.